February 1942, the North Atlantic. A Canadian naval officer stands on the frozen deck of HMCS Skeena, watching the horizon dissolve into white. The convoy route from Halifax to Murmansk has become a graveyard. 15 merchant ships lost in 3 weeks, not to U-boats, not to air raids, to the cold itself. Men abandon burning vessels only to freeze in lifeboats before rescue arrives. Others make it to the Icelandic coast or northern Norway and die waiting on the ice, visible from patrol aircraft but unreachable by any vehicle known to the Allied command. The problem is absolute. Tracked military vehicles sink through snow, wheeled trucks become immobilized within minutes, horses die of exposure. Dog sleds cannot carry the wounded or the volume of supplies needed to sustain advanced rescue stations along the Arctic coastline. The mathematics of the situation are clear and unforgiving. A man in wet clothing at minus 30 degrees Celsius has approximately 12 minutes before cognitive function fails. A ship's crew scattered across pack ice 3 kilometers from shore might as well be on the surface of another planet. In Ottawa, the National Research Council convenes emergency meetings. Military engineers propose experimental tracked snow vehicles based on tank designs. The prototypes are heavy, slow, and require specialized fuel that freezes at Arctic temperatures. The first field test in Labrador ends with the vehicle buried to its turret ring in powder snow, the crew evacuated by ski-equipped aircraft after 2 days. The second prototype breaks through river ice under its own weight. There are no further tests. But in Valcourt, Quebec, a village of fewer than 500 people, a man named Joseph-Armand Bombardier is already 10 years into a private obsession that began not with military strategy but with the death of his 2-year-old son. January 1934. His boy, Yvon, ill with acute appendicitis. The nearest hospital 18 kilometers away. The roads buried under 2 meters of snow after a 3-day blizzard. No vehicle could move, no doctor could arrive. The child died in his father's arms. Bombardier, a self-taught mechanic who had been building experimental snow vehicles since the age of 15, made a promise in the silence of that winter night. He would solve the problem of winter itself. By 1937, he had patented a revolutionary drive system, a sprocket and track configuration that distributed weight across a wide surface area, paired with a rear-mounted engine and a steering mechanism adapted from automotive technology. His first production model, the B7, could carry 7 passengers across deep snow at 40 kilometers per hour. It was used by country doctors, priests traveling between remote parishes, and telephone line repair crews. The Quebec provincial government purchased 12 units. Bombardier sold them from his garage workshop, manufacturing each component by hand with tools he designed himself. The vehicle was functional. It was reliable. But it was not a military asset. It had no armor, no weapons mounts, no consideration for combat logistics. Bombardier himself had no interest in warfare. He was a father, a husband, a mechanic whose ambition extended only to the practical problems of rural Canadian life. He had no formal engineering education, no government contracts, no connections to the defense establishment in Ottawa. He was unknown outside the province of Quebec. Then, in November 1941, a liaison officer from the Royal Canadian Air Force arrives in Valcourt. He is driven from Montreal on clear roads, but he has seen the reports from the Arctic convoys. He has read the casualty lists. He has attended the funerals. The officer's name is not recorded in surviving documents, but his instructions are explicit. The Air Force has heard rumors of a machine that moves across snow as easily as a truck moves across pavement. The military needs to see it. Immediately. Bombardier meets him in the workshop. The officer explains the situation without embellishment. Men are dying, ships are lost. The Allies cannot sustain the northern convoy routes without a solution to ground mobility in extreme cold. Can this machine operate at minus 40 degrees? Can it carry 1,000 kilograms of cargo? Can it travel 200 kilometers without refueling? Can it be manufactured in sufficient numbers to matter? Bombardier listens. He does not answer immediately. He walks the officer outside to where a B7 sits in the snow, engine cold, frost covering the windshield. He starts it on the first pull. The engine noise is steady, industrial, unglamorous. He gestures for the officer to climb in. They drive into the forest, onto trails that no automobile has ever touched, through drifts that would swallow a jeep entirely. The officer says nothing during the ride. When they return, he steps out, stamps snow from his boots, and asks a single question. How soon can production be scaled for military application? Bombardier's answer is conditional. He will need steel, rubber, precision tooling, access to industrial manufacturing equipment, labor. He will need government contracts that guarantee purchase orders large enough to justify expansion. He will need engineers who understand both mechanical design and Arctic conditions. He cannot do this alone from a village garage. The officer makes a telephone call from the Valcourt post office. Within a week, representatives from the Department of Munitions and Supply arrive with blueprints, specifications, and a list of modifications required for military deployment. The vehicle must carry 10 soldiers with full equipment. It must tow supply sleds weighing up to 1,500 kilograms. It must withstand sustained operation in coastal environments where salt spray and freezing fog corrode metal within hours. It must be simple enough that a field mechanic with basic tools can repair it under combat conditions. Bombardier begins the redesign immediately. He strengthens the track assembly, widens the vehicle body, installs a more powerful engine, and integrates a heating system that prevents crew compartment temperatures from dropping below freezing even when the exterior temperature reaches -50. He tests each iteration personally, driving through the Laurentian wilderness in the coldest months, documenting failures, refining solutions. His workshop becomes a hybrid space, part rural machine shop, part engineering laboratory. Local men are hired and trained. Bombardier's wife manages the administrative work. His brothers assist with fabrication. The village of Valcourt transforms quietly into a production facility that will soon operate around the clock. By spring 1942, the first military prototype is ready. Designated the B-12, it is larger, heavier, and far more capable than anything Bombardier has built before. It is also untested under true Arctic conditions. The Air Force arranges a demonstration at a forward operating base in Churchill, Manitoba, on the edge of Hudson Bay, where pack ice meets tundra, and the wind cuts visibility to zero within seconds. If the vehicle can function there, it can function anywhere the convoys operate. Bombardier travels north with 2 mechanics and a disassembled B-12 in a cargo aircraft. They arrive in Churchill on a clear day that feels like a gift. The temperature is only -28, the wind is calm. They assemble the vehicle in a hangar while military observers watch in silence, taking notes, asking no questions. When the machine is complete, Bombardier climbs into the driver's seat and starts the engine. The sound echoes in the cold air, mechanical and certain. He drives out onto the ice. The ice extends in every direction without feature or boundary. Bombardier drives the B-12 2 kilometers from the hangar, then 5, then 10. The machine responds to every input with mechanical precision. The tracks bite into hard, packed snow. The steering is stable, the engine temperature remains constant. Behind him, a military convoy follows in 3 jeeps struggling through drifts, falling behind within the first kilometer. Bombardier does not slow down. He continues north onto the bay ice itself, where the surface is wind-polished and treacherous, where pressure ridges rise like frozen waves and the ice groans under its own tension. At 15 kilometers, he stops. The observers reach him 20 minutes later on foot, having abandoned their vehicles. They are breathing hard, faces raw from wind exposure. Bombardier climbs out of the B-12 and walks a circle around it, inspecting the tracks, checking the undercarriage for ice accumulation, testing the tension of the drive belt with his hand. He finds nothing wrong. The machine is functioning exactly as designed. One of the officers asks how far it can go. Bombardier looks north across the bay and says he does not know. He has never had the opportunity to find out. They return to Churchill as darkness falls. The temperature drops to -37 overnight. In the morning, Bombardier attempts a cold start without preheating the engine. The B-12 starts on the second pull. The observers request a cargo capacity test. Bombardier loads the vehicle with sandbags until the suspension is fully compressed, then drives a 50-kilometer loop across tundra and through river valleys filled with deep powder. The vehicle does not falter. The fuel consumption is higher than predicted, but still within acceptable parameters for operational use. The military evaluation continues for 6 days. Each test is designed to find the breaking point: maximum slope angle, maximum sustained speed, resistance to lateral wind shear, response to sudden ice fracture, ability to tow disabled vehicles. Capacity to operate in whiteout conditions using only compass navigation. Bombardier passes every requirement. On the final day, a blizzard moves in from the northwest with winds exceeding 80 kilometers per hour. Visibility drops to less than 3 meters. The test is officially canceled. Bombardier ignores the cancellation. He drives into the storm with a military observer who volunteers only because refusing would look like cowardice. They are gone for 4 hours. When they return, the observer's hands are shaking, not from cold, but from the realization that they had traveled 30 kilometers through conditions that would have killed them in any other vehicle. The testing phase ends. The military approval is immediate. By May 1942, the Department of Munitions and Supply issues a contract for 200 units. Bombardier is given 4 months to deliver. It is an impossible timeline. His Valcourt workshop can produce 1 vehicle per week. Scaling to the required output will demand a factory, industrial tooling, a trained workforce, and a secure supply chain for materials that are already rationed for wartime production. Bombardier accepts the contract without negotiation. He understands that men are dying while he hesitates. Construction of the factory begins in June. The site is adjacent to his existing workshop, a flat parcel of land that floods every spring. Workers dig foundations in the mud. Steel framing arrives by rail from Montreal. Bombardier hires machinists from shuttered textile mills, farmers who have experience with engine repair, and young men rejected from military service due to minor medical conditions. He trains them personally, spending 16-hour days on the factory floor, demonstrating welding techniques, explaining the tolerances required for track assembly, troubleshooting problems as they arise. There are no formal engineering drawings. The design exists primarily in Bombardier's mind and in the prototype itself, which is disassembled and studied like a mechanical blueprint. The first challenge is the track system. Each B-12 requires 2 continuous rubber tracks reinforced with steel cables and fitted with precisely spaced drive lugs. The rubber must remain flexible at -50 degrees without cracking. The steel must resist salt corrosion. The manufacturing process involves vulcanization under high heat and pressure, a technique that requires specialized equipment and chemical knowledge that Bombardier does not possess. He contacts a tire manufacturer in Sherbrooke who agrees to produce the tracks under subcontract. The first batch arrives in August. Half of them fail quality inspection. The rubber compound is too rigid. The steel cables are misaligned. Bombardier rejects the entire shipment and travels to Sherbrooke to supervise the process himself. He spends 3 weeks in the factory, adjusting temperatures, modifying the mold design, testing each track personally in a cold storage unit. The second batch meets specifications. The second challenge is engine supply. The B-12 uses a modified Ford V8 engine, reliable and powerful, but Ford's Canadian production is entirely committed to military truck and tank contracts. Bombardier cannot access the engines through normal channels. He negotiates directly with a Ford plant manager in Windsor, arguing that the snow vehicle serves the same strategic purpose as a truck and should qualify for the same priority status. The manager is sympathetic but constrained by regulations. He suggests an alternative. Ford has a stockpile of engines that failed final inspection due to minor cosmetic defects, surface rust, small oil leaks, issues that do not affect performance but violate military acceptance standards. The engines are destined for scrap. Bombardier purchases the entire lot at a discount. His mechanics refurbish each engine by hand, replacing gaskets, grinding down rust, retorquing every bolt to specification. Not a single engine is wasted. By October, production reaches 12 vehicles per week. The factory operates in 2 shifts. Components are fabricated during the day and assembled at night. Bombardier is present for both shifts, moving between workstations, inspecting welds, testing steering mechanisms, ensuring that every vehicle meets the standard he demonstrated at Churchill. He sleeps 4 hours a night in a cot in his office. His wife brings him meals. His children see him only on Sundays, and even then, he is distracted, mentally calculating production schedules and material requirements. The first convoy of 20 B-12 vehicles leaves Valcourt in early November, transported by rail to Halifax and then by cargo ship to Iceland. They arrive in Reykjavik in late November and are immediately deployed to coastal rescue stations along the northern shore. Within 2 weeks, the first operational report arrives. A British merchant vessel, torpedoed 70 kilometers east of Iceland, managed to beach itself on pack ice before sinking. The crew of 32 men abandoned ship and began walking toward land in darkness and sub-zero temperatures. A patrol aircraft spotted them at dawn but could not land. The nearest rescue station dispatched a B-12 with a medical team and survival supplies. The vehicle reached the crew in 90 minutes, traveling across ice and through snowdrifts that would have been impassable by any other means. All 32 men survived. The report is forwarded to Ottawa, then to London, then to Washington. The demand for Bombardier's vehicles increases immediately. By December, the military contract is expanded to 500 units, then 800. Production bottlenecks become critical. Steel shortages delay frame fabrication. Rubber rationing limits track production. Labor turnover increases as workers are drafted into military service or leave for higher-paying factory jobs in urban centers. Bombardier responds by simplifying the design wherever possible, eliminating non-essential features, standardizing components to reduce machining time. He negotiates with the government for priority access to materials, arguing that each vehicle built represents lives saved and cargo delivered. He wins some concessions, others are denied. He adapts. In January 1943, a second report arrives from the Arctic. A convoy of supply trucks traveling overland from a northern Canadian airbase to a forward observation post became stranded in a 3-day blizzard. Temperatures reached -48 degrees. The trucks were buried. Radio contact was lost. A B-12 was dispatched from the nearest base with a rescue team. The vehicle traveled 230 kilometers through conditions that grounded all aircraft. It located the convoy by following the last known GPS coordinates, dug out the trucks, delivered fuel and medical supplies, and guided the entire convoy back to base. No casualties. The operation took 18 hours. The commanding officer's report described the B-12 as the most strategically valuable piece of non-combat equipment in the Arctic theater. Bombardier reads the report in his factory office. He does not celebrate. He returns to the production floor and adjusts the timing on an engine that is running 3 seconds slow. There are still 600 vehicles left to build. The war is not over. The ice has not melted. Men are still dying in the cold. He tightens a bolt, wipes oil from his hands, and moves to the next station. By March 1943, 147 B-12 vehicles are operating across the Arctic theater. They are deployed at rescue stations in Iceland, northern Norway, Greenland, and along the Canadian Arctic coast. They serve as ambulances, supply transports, reconnaissance vehicles, and mobile command posts. They operate in conditions that immobilize every other form of ground transportation. The survival rate for downed aircrew in Arctic regions increases by 62% in areas where B-12 units are stationed. Convoy resupply missions that previously required weeks of preparation and carried significant casualty risk are completed in days with minimal personnel exposure. The strategic impact is measurable and immediate, but the vehicles are also breaking down. The Arctic environment is more hostile than any testing ground. Salt spray corrodes electrical systems. Extreme cold causes metal fatigue in welds and joints. Fine snow infiltrates sealed compartments and freezes into ice that jams mechanical linkages. Track rubber develops stress fractures after sustained exposure to sub-zero temperatures. Field mechanics submit detailed failure reports. Bombardier reads every single one. He identifies patterns. Certain welds fail at predictable stress points. Specific gaskets lose integrity after 300 hours of operation. The drive sprocket teeth wear unevenly due to ice accumulation. He begins issuing technical bulletins with modification instructions. Reinforce this weld with a gusset plate. Replace this gasket material with a cold-resistant compound. Install a scraper blade to prevent ice buildup on the sprocket. The modifications are distributed to every unit in the field. Mechanics implement them using available materials and improvised tools. The failure rate drops. Vehicle operational availability increases from 71% to 89% within 2 months. Bombardier does not wait for problems to reach critical mass. He redesigns components preemptively, testing them in Valcourt's cold storage facility and shipping improved parts to forward bases before the original parts fail in service. In June 1943, the Allied command requests a specialized variant, a vehicle capable of transporting critical intelligence personnel and sensitive equipment across hostile Arctic territory with minimal detection risk. The B-12 is too loud, too visible, and too large for covert operations. Bombardier is given 3 weeks to develop a solution. He responds by designing a smaller vehicle, a 2-person unit with a quieter engine, reduced visual profile, and the ability to tow a camouflaged cargo sled. The prototype is built in 11 days and tested in Labrador under simulated operational conditions. It passes evaluation. 20 units are manufactured and deployed to Norwegian resistance groups operating behind German lines. The vehicles are used to evacuate Allied operatives from coastal drop zones, transport sabotage equipment to inland targets, and conduct reconnaissance missions across frozen fjords, None of the vehicles are captured. Several are credited with enabling operations that disrupted German Arctic supply lines. By autumn 1943, Bombardier's factory is producing 30 vehicles per week. The workforce has expanded to 270 employees. The production process has been refined to the point where a vehicle can be assembled from component delivery to final inspection in 68 hours. Quality control is absolute. Every vehicle is test-driven for 50 kilometers in loaded configuration before acceptance. Every engine is run at full throttle for 2 hours under observation. Every weld is visually inspected. Every track is tension tested. Bombardier himself signs off on each vehicle before it leaves the factory. His signature is not ceremonial. It is a personal guarantee. The winter of 1943 brings the coldest temperatures recorded in the Arctic in 20 years. Sustained periods of -50 degrees, wind chills approaching -70, conditions that kill exposed human tissue in under 2 minutes. Several convoy routes are declared temporarily impassable. Aircraft are grounded for weeks, but the B-12 vehicles continue to operate. A medical evacuation from a remote Norwegian coastal station is completed in a 72-hour journey through a polar storm. A supply convoy delivers 12 tons of ammunition and fuel to a forward airbase that had been cut off for 17 days. A search and rescue team recovers the crew of a downed bomber 40 kilometers inland from the crash site, traveling through darkness and whiteout conditions using only dead reckoning navigation. The rescues accumulate. The lives saved are counted. The strategic value of Bombardier's invention is no longer theoretical. In February 1944, a classified report is submitted to the Canadian War Cabinet. The report summarizes the operational history of the B-12 vehicle program. It documents 863 confirmed rescue missions, 4,212 personnel evacuated from life-threatening situations, over 9,000 tons of supplies delivered to otherwise unreachable locations. The report concludes that the vehicle has contributed more to Allied Arctic operations than any single piece of equipment short of the convoy ships themselves. It recommends that Bombardier be awarded a national commendation. The recommendation is approved, but the award is deferred until the war's conclusion to avoid drawing attention to strategic assets still in active deployment. Bombardier does not learn of the report. He is occupied with a new problem. The military has requested a vehicle capable of operating on both snow and open water, an amphibious snow vehicle for coastal operations where sea ice is unstable and terrain alternates between frozen land and frigid ocean. The engineering challenge is formidable. The vehicle must be watertight, buoyant, propelled by both tracks and a marine drive system, and capable of transitioning between modes without stopping. Bombardier begins the design work immediately. He collaborates with marine engineers from the Royal Canadian Navy. He tests buoyancy configurations in a flooded quarry near Valcourt. He modifies the track system to function as a paddle wheel when submerged. The prototype is ready in August 1944. It is tested in the Gulf of St. Lawrence under observation by naval officers and Coast Guard personnel. The vehicle successfully transitions from land to water and back, maintains stability in 2-meter swells, and achieves a water speed of 8 kilometers per hour. The military places an order for 50 units. Production begins in October. The war in Europe ends in May 1945. The Arctic convoys cease. The demand for military snow vehicles collapses overnight. Bombardier's factory, which had been operating at full capacity for 3 years, suddenly has no orders. The workforce is reduced by half. The remaining employees are reassigned to peacetime production. Bombardier himself returns to the work he began before the war. Vehicles for rural doctors, vehicles for remote communities, vehicles for telephone line crews, and forestry workers. The machines that had saved thousands of lives in the Arctic are now used to deliver mail and transport schoolchildren. But the engineering knowledge remains. The lessons learned in the coldest, harshest environment on Earth are applied to civilian designs. Bombardier refines the track system, reduces manufacturing costs, improves fuel efficiency. In 1959, he introduces a single-person snow vehicle, compact and maneuverable, designed for individual transportation across winter terrain. It is called the Ski-Doo. The name is a typographical error on an early promotional brochure. Bombardier keeps it. The vehicle becomes a cultural icon, a tool of recreation and utility that transforms winter itself from an obstacle into an opportunity. Joseph-Armand Bombardier dies in 1964 at the age of 56. By then, his company employs over 8,000 people. His vehicles are used in 32 countries. The Ski-Doo has sold over 250,000 units. The company that bears his name will go on to manufacture aircraft, trains, and transportation systems that move millions of people across the planet. But in the winter of 1943, in the frozen silence of the Arctic, the legacy was already established. Not in sales figures or corporate expansion, but in the simple, inarguable fact that men who should have died lived instead. The Canadian military decommissions the last B-12 in 1967. Several are preserved in museums. One remains in Valcourt, parked in a climate-controlled building adjacent to the original workshop where Bombardier built his first prototype. The vehicle is not operational. The engine has been drained. The tracks are brittle with age. But the structure is intact, the welds are still sound, the steering mechanism still turns. If fuel were added, if the engine were primed, if someone who understood its design were to climb into the driver's seat, it would almost certainly start. Not because the machine was overbuilt or unusually durable, but because the man who designed it understood that in the Arctic, reliability was not a feature. It was the difference between survival and death. There is a plaque mounted on the wall above the vehicle. It lists the number of confirmed rescues, the tonnage of supplies delivered, the operational range achieved under extreme conditions. The statistics are impressive, but they do not capture the full measure of the contribution. They do not account for the missions that succeeded because a vehicle was available when it was needed. They do not count the convoy routes that remained open because ground mobility was no longer impossible. They do not quantify the psychological impact of knowing that if a ship went down, if an aircraft crashed, if a storm cut off a forward base, there was a machine that could reach the stranded, the injured, the isolated, regardless of weather or terrain. Bombardier never sought recognition. He avoided interviews. He declined public appearances. When asked about his wartime work, he spoke only of the vehicle itself, its specifications, its capabilities, its limitations. He deflected credit to the mechanics who built it, the soldiers who operated it, the engineers who improved it in the field. He described the B-12 as a solution to a mechanical problem, nothing more. But the men who rode in those vehicles, who waited on the ice for rescue, and saw the shape of a Bombardier snow machine emerge from the blizzard, understood the truth. The machine was not just a vehicle, it was a promise, kept in metal and rubber and gasoline, that winter and distance and cold would not be allowed to kill without a fight. In the archives of the Canadian War Museum, there is a handwritten letter from a Royal Canadian Air Force pilot dated March 1943. His aircraft had been forced down on the Greenland ice cap during a navigation training flight. He and his co-pilot survived the landing but were stranded 60 kilometers from the nearest base in deteriorating weather. They activated their emergency beacon and waited. A B-12 arrived 19 hours later. Guided to their position by radio triangulation and the skill of a driver who had never seen the terrain before. The letter describes the sound of the engine cutting through the wind, the relief of seeing another human being, the warmth of the heated passenger compartment. The pilot concludes the letter with a single sentence. He says he will never forget the face of the driver, a French-Canadian mechanic who spoke almost no English, but who navigated 70 kilometers of featureless ice and darkness to bring two strangers home. That driver's name is not recorded. Neither are the names of most of the men who operated the vehicles, who maintained them in brutal conditions, who drove them into storms to retrieve the lost. Their service was not ceremonial. It was not celebrated with parades or medals. It was simply performed day after day, in the coldest corners of the war, where the machinery of survival was tested against the physics of extinction and proved sufficient. Joseph-Armand Bombardier built that machinery. He built it from grief, from necessity, from an unshakable belief that human ingenuity could overcome the most hostile forces of the natural world. He built it in a village workshop with hand tools and the knowledge that came from years of failure and iteration. He built it without formal training, without government funding, without any expectation that his work would matter beyond the boundaries of rural Quebec. And when the world needed what he had made, when men were dying in the ice and no solution existed, he scaled his invention from a garage project to an industrial program that saved thousands of lives and changed the course of Arctic warfare. The legacy is not in the museum displays or the corporate history or the technological evolution that followed. The legacy is in the survival of men who would have died. That is the measure. That is the monument. A snowmobile, repurposed from civilian utility to military necessity, driven by ordinary men through extraordinary conditions, proving that even in the coldest, darkest, most unforgiving environment on the planet, someone would come. Someone would drive through the storm. Someone would bring you home.